X and Y, a real introduction to real mathematics. Long ago, I have discovered that revealing the fraud of modern education and having crazy amounts of fun while learning it for real is one and the same. Before I babble any further, I wanted to share a program I just made for all of you. You can find it at editor.p5js.org/catp/sketches under the name Math 101, and on GitHub at github.com/catp/p5. Catp is spelled CATPEA, and P5 is lowercase letter p followed by number 5. This is almost exactly the same kind of program I wrote when I stopped learning in school because of bullies and being accused of copying when I was writing my own programs. I must have been 10 years old or so. What you will discover in this program is coordinates of 0, 0 in the lower left-hand corner, as it should be, and a tree with 4 generations of branches, red, green, blue, and magenta. The code is very plainly spelled out, not in a loop, not in a function even. Just friendly computer math that solves itself. And then at the end, when branches get too small to do anything with them, I do make a loop, just to show you what loops look like, and to finish off the top of the tree. This tree is very special, because it represents plain math, the math we use every day. But to fix the branches of the tree, to make them more realistic and artistic, like in Brett Victor's Inventing on Principle, we can't just use plain numbers. We need to upgrade them to something more capacious. The numbers we use every day are called scalar. The upgraded numbers are called vectors. Vectors store a value plus an angle. And this is what we need for our tree. We need to say that this branch is 20 pixels long, but at 15 or 30 or 45 degree angle. We can't do this with scalar numbers, because when you have things at an angle, they can't be calculated with subtraction and addition, like I'm calculating at the first level of branches. The tree branches won't be the same length. They won't align in a circle. So we need to let go of X and Y and focus on line length, which will be the same for all the branches at a particular level, and angle, which will differ for all the branches, probably in 15-degree increments, kind of creating a little fan of branches. Look at a real tree. Branches in the middle are almost the same length, and branches at the very ends are pretty short. Any source of information on the subject of vectors will give you all the formulas. They are all very easy to implement too. But there is a little bit more to it, because angles mean circle. That's where all the pi always comes from. And the consistent lengths of the branches is just the circle radius. We choose angles because that's how branches grow on a tree. And angles are best handled by means of circles. And what is really cool is that a radius of a circle makes for a fantastic representation of the length of a branch of a particular height on our tree. To angle our virtual branch, we draw a line at an angle starting in the middle of the circle. At this point, we arrive at another area of mathematics, trigonometry. Trigonometry is just relationships of lines moving around a circle. This is never explained correctly in school and never given any real context. This is what our tree represents: a need for vectors, vector operations, and the underlying trigonometry. You know, trigonometry is all about relationships between lines and angles that are somehow connected to a circle. And the reason why that's a big deal is because sometimes we only have a little bit of information, such as the length of a branch and an angle. And we need those relationships to figure out how that translates to from the length of a radius and an angle to an X and a Y on a grid, like in our drawing of the tree here. I know that trigonometry makes people sad. It represents failed tests, sometimes tears. But trigonometry is just relationships between lines, triangles, and circles. They can't hurt you. Do not be sad. Get mad. Because trigonometry is less than 50 lines of code. It is just that it has been mishandled by schools and math teachers. The only big thing about trigonometry is that people studied all those relationships and shared the formulas that they cooked up and the knowledge about all the different ins and outs. As a result, we can just use their more general formulas rather than inventing our own for a tree branch. Our own would just be a smaller version that only deals with representing branches for our tree. Inventing the formula would actually need to use a triangle, just like in trigonometry. So it's a good thing that we don't need to reinvent something. I hope the tree will call to you. I hope the fact that I just used scalar subtraction and addition, instead of cool vectors, will call to you. I don't know what this memorization nonsense that schools are doing is, but I swear to you, it is not math. If anything, they are destroying math. They are not teaching it. What I just showed you is the real math. It is interesting and colorful and useful and often set in some kind of a mystery, like the branches of our tree here. Real math can make us dream about generating infinite forests of unique trees. And why stop at the trees? We can add birds to the trees, and generative squirrels, and little chipmunks in various poses, and an odd bunny here and there, and 2 deer with universally unique antler configurations. Oh yeah. And why not a cat or 2? They always seem to be everywhere. Put a lion in there as well. Why not a lion? Personal note. In order to capture the perfect lion roar, I have recorded several lion noises that I figured I should share at the end of the text. Meow, meow, wow.